Welcome to The Explainer. Today, we're going to break down exactly how modern apps keep your account secure. We'll dive into the two key pieces of tech that make it all happen: password hashing and, of course, JSON Web Tokens. So let's just jump right in. Have you ever really thought about it? When you log in, what's happening behind the scenes? Well, any secure login system has to solve two major problems. First, how do you store a user's password without, actually storing it? And second, once they're logged in, how do you keep them logged in without asking for their password on every single click? And these two challenges, protecting the password in the database and proving you're logged in, are totally different. They're like apples and oranges. So naturally, they need two completely different solutions. Let's tackle that first one, storing the passwords safely. To really get our heads around protecting passwords, we need to talk about a process called hashing. It sounds complicated, but the core idea is actually super simple. And the best way to think about it is with a coffee grinder. This is just a brilliant analogy because it gets to the heart of what hashing is all about. It's an irreversible process. Once you take your password, that's the coffee bean, and you grind it down into a hash, the coffee grounds, there is absolutely no way to turn it back into the original bean. It's a one-way trip. So here's what happens. When you sign up for a service, you give them your password. The server immediately throws it into that coffee grinder, a hashing algorithm, and it stores only the scrambled up grounds. Your actual password? It's never even saved. So even if a hacker gets their hands on the entire database, what do they find? Just a bunch of useless coffee grounds, not your password. And that is the whole point. Hashing is destructive by design. Its job isn't to hide information, it's to verify it. So when you log in again, the server just grinds the password you just typed and checks if the new grounds match the old grounds. That's it. It never needs to know what the original bean was. This is where a lot of people get tripped up. They think hashing is just a fancy word for encryption. It's not. Encryption is a two-way street. You lock something with a key, and you can unlock it with the key. Hashing is a one-way street, which is exactly what you want for passwords. You never want them to be unlockable. Okay, so your password is safe and sound, ground up into a hash in the database. Awesome. But now what? How does the app know it's you as you click from page to page? Sending your password over and over again would be a terrible idea. This is where we need a whole new tool, and it's called a JSON Web Token, or JWT for short. And the movie ticket analogy is just perfect. When you log in correctly, that's like buying your ticket at the box office, the server hands you a JWT. From that point on, every time you want to do something, like go into the theater, you just show your ticket. The server just glances at it to make sure it's a real, valid ticket. That's it. Okay, but what makes this ticket secure? How does the server know you didn't just print a fake one at home? Well, it all comes down to one thing: the digital signature. This signature proves two absolutely critical things. One, that the token really did come from the server, and two, that nobody has messed with it. So let's break this down. What can a hacker actually do if they get a hold of your JWT? Well, they can definitely read what's inside it. It's not encrypted. But can they change it? Nope. If they try to change the user ID to make themselves an admin, for example, the signature won't match anymore, and the server will just laugh and throw it out. And they can't create a new token from scratch because they don't have the server's secret key to create a valid signature. And this leads us to the absolute number one most important rule of using JWTs. Please burn this into your brain, because anyone can read the data inside. You should never, ever, ever put sensitive stuff in there. No passwords, no credit card numbers, nothing. Just think of it like a postcard. Anyone who picks it up can read the message. So, just to put a bow on it, every single JWT has these three parts, usually separated by little dots. You've got the header, the public payload with stuff like your user ID, and then the most important part, the signature, that holds it all together and keeps it secure. All right, so we've got our coffee grinder for sign up and our movie ticket for staying logged in. Now let's put it all together and see the full picture. This is how hashing and JWTs work hand in hand to create a really secure system. So here it is, the whole dance from start to finish. Step 1, you sign up and your password gets hashed. Step 2, you log in, the server hashes what you just typed, checks if it matches the stored hash, and if it does, it gives you a shiny new JWT. Step 3, for everything you do after that, you just flash your JWT, the server checks the signature, and you're in. It's actually a really elegant solution. Okay, so we get the theory, but knowing the theory and doing it right are two different things. Let's talk about the golden rules, the absolute non-negotiables for making this stuff actually secure in the real world. First up, the must-do list. You have to use a modern hashing algorithm, something slow and tough like Argon 2. Your secret key for signing JWTs needs to be super long and totally random. You want to keep your JWTs lifespans short. Think 15 minutes, not 15 days. And of course, always use HTTPS to protect that token while it's traveling over the internet. And just as important is the never ever do this list. I know we've said it before, but it's worth repeating. Never store passwords in plain text. Never put sensitive data in a JWT. And please avoid old, weak hashing algorithms. They're basically useless against modern attacks. And look, if you need one last reason why this matters so much, check this out. Trying to crack 1 million passwords hashed with an old algorithm like SHA-256, an attacker could do that in about 2 minutes. But with a modern algorithm like Argon 2, that same attack would take almost 6 days. You've just turned a 2-minute disaster into a 6-day warning. That's a game changer. Okay, so we've got this all figured out, right? We have short-lived JWTs for security. But wait, you know how you stay logged into websites for weeks? How does that work if the tokens expire in 15 minutes? Well, that, my friends, is the next piece of the puzzle. It involves something called a refresh token, and it's the key to building a truly user-friendly and secure system.